This is Jared at the 2011 JPL Tweetup, and let's go ahead and go inside and see what's happening since I'm here for the Columbia Memorial Space Center today, and we're going to see what happens. So Doug Ellison, one of the people here at JPL, has told me that this is what's called a SEP nut, and what this is this actually separates parts of the spacecraft. So up here in this spot there's two pyro charges up there, one that works, one for redundancy, and what it does is it fires like a shotgun and it destroys that metal part right there, and it can actually release, it's sort of like an explosive bolt right here. So that's at our table.
I hear you're part of Caltech, and it gets confusing. Even the reporters who cover our missions ask us all the time, what is this connection between JPL, Caltech, and NASA? So,
like this. We're sending spacecraft to visit truly uncharted worlds. And you know, when you look at a picture like this and compare it with something like California, this is deceptive. This is largely flat, right? But these are round, three-dimensional. Again, they're worlds.
We're sitting right out here on the cusp of crossing the heliopods. Voyager 1 is a little bit up here, and Voyager 2 is a little bit down here. Okay, we're in this area called the helio sheath. We anticipate that it's going to be about another 3 to 5 years until we go across that heliopause boundary.
So here's what we're going to do. We're going to take this balloon, and we're going to come over here, and I'm going to hold the flame to it, and you guys tell me what's going to happen, all right? All right, here we go. Ready? My big light. Here we go. 1, 2, 3. Oops. It was raining. Okay, very excited. Okay, so now what we're going to do is we're going to do this same trick, but with a water balloon. And what you're going to see is that the water balloon actually will not break. And the reason it won't break is because the water is so good at I've never broken the balloon yet. Ooh, I've gotten really bad at putting on my coat, though. Right. Okay, forget it. I promise it won't break. It'll be fine. There we go. Okay, so we're going to take the water balloon and give this a try. You guys might want to shoot. I'm just kidding. I promise it won't break. Here we go. Okay, you ready? So we're going to count how long it takes before we all get bored and the balloon breaks. You ready? Everybody see that? Actually, the flame is touching the balloon, in case you can't tell. So I had a friend whose husband is a stuntman, and he actually tried this with a giant Bunsen burner, and he still couldn't break the balloon. Oh, I will say that a blowtorch does do the trick.
You're right, the best group?
Group one.
Oh, sorry.
Oh, you said something. Whoa, hey.
Whoa. First faux pas.
We want a new tour guide. We're in the House Gryffindor here, all right?
Well, we're delighted to have you no matter what number they assign you to sorting. And this is our newly refurbished museum as of about a year ago or so. What you'll find on the north wall, you can walk around, we've got pretty much one panel display per planet as we head around the rocky terrestrial inner planets there, through a little Mars section around on their east wall. Of course, we have to navigate and get through the asteroid belt before we can get to the outer solar system back here. Onto space telescopes, largely in the infrared. Whitney can talk about that. We have an infrared camera here. We've got aerogel against the wall, lightest solid in the world in the Guinness Book of World Records. Almost light enough to float in air. It's amazing stuff. To use a thermal insulator, and also on the Stardust mission to bring comet particles back to Earth. Around front here we have a full-scale Mars rover, which is we have this Sojourner rover from Mars Pathfinder, microwave oven size or child wagon size. That's our 1997 rover. And we've got the Mars Exploration rovers, Spirit or Opportunity. They're twins, so this is a full-scale model. And these are the ones that are still going, at least one of them on Mars. And of course, outside you might have seen an inflatable Curiosity. That's the next big bad rover, which you'll see the real thing later today when you go to the spacecraft assembly facility. Other than that, feel free to wander around. Your tour guides will be around. We'll take questions, and hope you have fun today. Thanks for being here.
Thank you.
As you guys know, but this was up. So you already know. But basically, the infrared light coming from our bodies is being translated into visible light colors in the same way that we create these gorgeous pictures of the space and cosmos as a supernova remnant, and this is the Pleiades, and we see these things in visible light because the infrared light's been translated into visible colors we see with our eyes. And so this camera is sort of demonstrating how that works, where the longer wavelength light of infrared is coded into the longer visible light. It's actually, no, it's reverse of this one. They didn't do it that way. But anyway, that's in our pictures. We keep the wavelengths like ordered in the right order. And so you can see my lips are very cold, and that's why they're the darkest colors. And then, oh, now I look scary. It's so funny because when it drips on me, I think I've gotten something on my clothes, but yeah, it's just water. So feel free to play with it, and then let me do one last demo. So one of the reasons we have infrared telescopes is we want to see behind dark clouds. And a visible light, like if this is a dark cloud in space and there's newborn stars behind it, we can't see them. They're being blocked by this dark cloud. But the infrared light from the stars will break through the cloud. So I can demonstrate that here, this bag. Because you see, my hand shows up in the infrared. I can actually see through the bag in infrared. And that same thing is happening with Spitzer. Even in that far picture right there, these called mountains of creation. Some of those stars keep forming in those big pillars of dust. Can't be seen in visible light, but we can see through the pillars of dust and see them with Spitzer. And then WISE does the same thing, but it scans the whole sky. So it's getting all sorts of stuff, all sorts of pretty pictures, and it's finding asteroids and stuff like that. It's getting warming my hair up.
Let's see, what else can we do?
We need a big guy like you in space to warm up some of these stars we still can't see.
Let's see,
I
what
think
else
there's
we got?
logistical difficulties there with delivery.
Getting into space, yeah. But it would be a cheaper mission than normal.
So you can, let's see, I think you can just cool off your, cool off your shirt. It's fair up there.
Oh, look at that.
Yeah.
You got lots of cool tricks.
You have a piece of paper, that's always a fun one. You can, let's see. Yeah, let's see if I can. So that's usually cold, but the same thing kind of holds. You can see right through it. Put your heat signature on. Or I hate to do this too. No germs, but it's fun. It's kind of fun too. So okay.
Let's go out of full screen. And I'm just going to load one spacecraft. Let's look at Aqua. Aqua is an Earth observing spacecraft that takes loads and loads of different data sets using an instrument called AIRS. And I'm just going to bring one of them. This is its measurements of carbon monoxide. And you think, well, that's a little bit kind of flaky, there's big holes in there. But that's today's data, okay? That's bang up to date. And there's about a dozen different data sets you can look at that are absolutely bang up to date. But what we do is take 3 days of this and average them together to fill in the blanks. What's there is symptoms of orbital mechanics. If you take 3 days and average them together, you get a map like this. And let's put a floodlight on. And so you can see that data around the globe. And this isn't just a pretty picture. If I leave the mouse over LA, bottom right-hand corner there, 105 parts per billion. This isn't just a pretty picture. This is quantitative data that you can get hour by hour, day by day, in real time in your browser. It's an absolutely fantastic tool. I'm going to show you one more spacecraft before I go and talk about eyes in the solar system. I'm going to talk about the GRACE spacecraft, because you just got that fantastic introduction to the GRAIL mission about mapping the gravity on the moon. And GRAIL follows a terrestrial equivalent called GRACE, which has been mapping the same thing but here on the Earth. And so the 2 GRACE spacecraft orbit in the same way as GRAIL will around the moon, and we can bring in that data as well. This is the same sort of data that you saw, but mapped onto the Earth. And you can animate this over time. You can say, you know what, I want to see a year's worth of this data. I want to watch all of 2009. And it says, you know what, I need to download quite a lot of data for that. So away you go, it downloads the data. And you'll see that we can animate this just like you saw in that 3D movie. Almost everything you saw in that movie you can do at home inside your browser. Let's hit play. We start animating that data set on the globe. And again, it's quantitative, it's not just a pretty picture. Expressed in the equivalent weight of centimeters of water. You can see in France there, it's losing a couple of centimeters, gaining a couple of centimeters. You get these patterns looping as the seasons go on. And as the movie mentioned, you get these ebbs and flows around the whole of the planet. You can get tropical rainfall and then a summer season. But Greenland is just getting lighter and lighter and lighter. it's not just a pretty picture, this is real data. And one thing we can do to really exaggerate this is do that. And suddenly South America gets very excited indeed. That's not my joke, that's my boss's, I apologize. So this
to them. We didn't ask them to go and write a song. We didn't ask them to produce music. But they were so excited about the information that they went and they did it anyway. And they created something that was just astounding. They had really learned something in this project, not only about Mars science, not only about learning technology skills, but about green design, about their own community, and they figured out a way to express themselves that was just amazing.
All right, here we go, y'all. We're recording. We're rolling.
We done made a habitat. How they figure that?
Okay, people. This is about that time. Come on, man. Let's not be around here. It all time, and it seems like we're about to blast off in 5, 4, 3, 2. You got it, man. You can do it, brother. Okay, come off the ship, people. We done finally made it here. Yeah, I know it's cold, but just come out of the habitat. You're gonna be warm. So check this out.
Okay, people, whole time we done had fun. It took things been running, but now we gonna show them running. It's a cold planet, so we doing damage. Put on your boots and space suits, we about to go and have it. We done made a habitat, how they figure that? So we about to go and show them how to live on that red planet. Man, it's oh so cold. You think it's hot, but we like no, it's cold, so okay. Now get out the ship. We up against habitat over there. Plant them tricks so we can come to land right. I can take up on the back and take flight. We're gonna be going to the services and now.
It's like a super villain's lair.
That's what I thought. You might want to try to get it cut off.
Is everyone here?
I just don't know how many people are. I mean, if you wanted to split it, you might want. I'm just saying, you might want to cut us off.
It looks about right.
Yeah.
Okay, so right, okay.
That's when you turn off the flash.
You did?
Tweeted your picture with chickens.
Oh, excellent.
I found your page too, Galileo.
Not often.
Very impressive stuff. You had a few stragglers.
Instruments, so we've got like the remote sensing mast in white, tall tower. On the front of this hexapod down here we have the duplicate arm, and then we also have the high gain antenna. So next week all these instruments are going to be populated onto our stunt double rover. So right now it's been going through all its internal electronics being populated for the past like 3 weeks, 2 weeks. So it's going to be really cool when we get everything back together and it looks like the flight rover. So if you guys have any questions, I'll try to answer.
Yeah, you were right behind me though.
Yeah, so
No,
that's
the 210 it's strange. It's strange that there was them getting sucked in here because that rover is very, very similar to Spiritual Opportunity. It's serial number 3 or 4, straight on TDO 1 and 2, and then these are 3. And apart from the solar,
How long did it take you to get down here?
it's entirely flight ready, so it's radio's work. Nothing's listening, but the radio's work.
I stopped at Starbucks on the way.
Background is the northern lights. So I see the star.
Thank you.
The crane is there.
And I love the fact that it's got all the like gold and red on it. It totally looks like a hot
Iron Man.
Yeah, that too.
I like Hot Rod better. Not a big fan of comic books.
Well, but considering that, you know, Iron Man's colors are designed off Hot Rod colors anyway.
True.
Did they say flashes off? Or?
It didn't, but I assume so.
Okay, so you can continue to do that, but I'll tell you a little about this mission. This is the next big rover mission to Mars. It's called the Mars Science Laboratory. The rover is called Curiosity, and we're launching it in just a few months now. It launches the day after Thanksgiving this year. About 3 weeks to get off the ground, and then we'll land on Mars in August of 2012.